My name is Sean Jones. Welcome to the beginning editing session on the SDK focusing on the edit operation. With me is Narelle Chedzi, and we are on the editing team in development at Redlands, California. We're part of the team that bring you the editor and also the SDK part of it as well. So let's take a look at what we're going to look at in this hour-long session. Take a brief overview of how editing works in Pro compared to other systems. Perhaps you've come from ArcMap. Are you guys all ArcMap or ArcObjects developers? You're probably familiar with that. Anybody not use Pro at all or how to play with it? There's one or two people. I'll just take you through the basics, the theory of how we change things in Pro. Then we'll take a look at the edit operations themselves, the basic workflows, this inspector class that we use to update the attributes, and if we have time, we'll get onto annotations and dimensions. Hopefully some people use annotations, you probably don't use dimensions. All right, so let's take a look at what we have done differently in Pro with editing. So simply to make an edit, we can simply just go to the Edit tab and let me make a selection of some features here. Here I've got some polygons and a point. So I'll do the simplest edit we can find, which is simply just deleting those particular features. So assuming that I've got all permissions, this is a file geodatabase. I can just select these features from two different layers and then simply hit delete. So a couple of things have happened here. Save and discard have lit up for me. So that means that I'm in an edit session. So what the delete has done is it said it's gone out to the work tab, which layers those features belong to. It's gone out to the workspace and it said start an edit session on that workspace. And then in Pro, if that succeeds, then it lights up the save and discard button so you know there's an actual edit session actually occurring. If we look at the data stores or the workspaces for the project, we can see that we've got two distinct workspaces here. So we no longer have that restriction that we had in ArcMap. We can edit multiple workspaces. Pro doesn't care. We're just editing layers and we're just editing features in those layers. When I did the delete, we put that on the undo stack. For file geodatabase, that's pretty typical. Some file systems, for example, you won't get an undo operation occurring, feature services, for example. So the particular edit operation, we'll call it, has gone on the undo stack. If I just undo that, the features come back. Notice that discard doesn't go away. So we're still in an edit session technically because we had those edits on the stack. The workspace is still in an edit session as well, and all the normal locking rules actually apply. If I'm happy with the edit, say redo, I can then either hit save or discard, and that will save and discard those features, but it will also close that edit session for me. So it'll unlock the workspaces. It'll close the edit session on those individual workspaces. So if we just discard that, for example, and say, yes, features come back and Pro is no longer in an edit session and other people can edit those particular workspaces. A lot of people didn't like us taking away start editing. Does anybody not like that? It took us a long time to get to this point. When we first started Pro, we did have a start editing experience, but it was getting very convoluted in terms of, because we have multiple workspaces, multiple maps, it was hard to work out a UI in terms of, well, what does the user actually want to edit? And so this experience was getting really complicated, and so we just decided to throw it all away and go down to this simple approach of make an edit on demand, if we had the permissions. It's not out of the question that we may go back to that someday, but not in the short term anyway. Okay, so that's editing in a nutshell. Let's talk about what it actually looks like from the SDK. All right. So the edit operation class is the primary pattern for editing in the Pro API. It performs a number of functions. One is that it provides all the methods and properties to enable you to do an edit within Pro. There's another API, which is the Geodatabase API. That's used in special circumstances. We don't actually cover that in this session. It's covered somewhat in the intermediate and advanced sessions. Yeah, there's a Geodatabase specific session as well. It consolidates multiple edits into a single operation. So you can do 100 creates or 1,000 modifies or lots of deletes, and they'll all get condensed into one operation, or they can do if you include it in one edit operation. We'll talk about that in a sec. Invalidates the underlying caches. Pro is really built on a number of caches. So there's a display cache, there's a feature cache, and that's how it gets its performance to some extent. By using the edit operation, the plumbing behind that just maintains all these caches and makes sure that everything displays properly as it should. The other big thing it does in the background is it enables us to edit multiple workspaces at the same time. So it takes care of all that plumbing to see if anybody's editing a workspace. It'll start an edit session on that workspace and maintain that edit session throughout the edit. So all that's sort of handled in the background for you. So what's the workflow to make an edit through the API? It's simply instantiating a new edit operation. You then specify all the edits that you want to perform in that particular edit operation, and then you simply execute it, which does all the magic. And we'll go through each of these one by one. So creating a new edit operation, simply just instantiate a U1 with a new keyword. The most common whoa, whoops, what happened there? Okay, it's locked out. What I was trying to do was this guy. Thanks. Where was I? Oh, yeah. So the edit operation has a bunch of properties associated with it that you can set. You can either do this in the constructor or set it after the event once you've got the variable. The names are probably the common one that you'll set. This is the name that gets assigned to the edit operation in the undo stack. So when people go to the undo stack and they see created X number of features, that's where it gets this string from. You can set an error message, progress a message, not that common to use. Select new features. If you want to select new features at the end of the edit operation that you create, these are set to true by default, the select modify and select new. So you normally don't have to set those. You really only set them if you want them to be false. So perhaps I don't want to select the features at the end of this edit operation. And down the bottom here is a sample snippet of code about seeing how easy it is to create. In this case, it's actually done in the constructor, so it's just setting the property names there. Okay. So the usage. So this is where we create, update, and delete our features. If you look at edit operation in the browser, you'll see there's a whole bunch of methods that we put on there. And these really represent what you're seeing in the UI. So you will find the cuts and the clips and the reshapes, explodes, etc. They all exist as methods on the edit operation itself. Most common ones you'll be using, create, modify, delete. When you try to do an edit, or when you call one of these methods, the parameters are usually giving it a map member and an OID. So the other big thing for us in Pro is the notion of a feature doesn't really exist for us in the editor itself. We usually reference a feature by a combination of the map member, which is just a layer in effect, and the OID. So the concept of the feature kind of does exist in the geodatabase, but it doesn't really make it up to our level. And that's mostly just because of the architecture that we've gone with Pro. So it's a bit different if you're used to dealing with features, particularly in ArcObjects. It's just a different pattern, if you like, to get your head around. Lots and lots of overloads. So the create method itself has something like 13 overloads to create features using a bunch of combinations in a layer, in a table, using geometry, using a dictionary of attributes. We'll go through some of these, but there are lots and lots of overloads for each method in there. I think modify has a bunch, delete doesn't have that many. There's no limit to how many things you can specify in one edit operation. So if you want to create 1 million features, you can certainly do that. We've tested it. Well, I had tested it with about 2 million features. It takes a long time, but it does actually work. And once you execute all those, it actually just appears as one item in the undo stack. So there's no real limit. I'll get to what is important in a second. Each operation must be specified independently. What this means is you don't want to do an edit that's dependent upon the outcome of a previous edit. So for example, I might do a reshape of a feature and then I may do something else to the geometry, and you can't really depend on the reshape has happened first before some other geometry operation has occurred, if that makes sense. because the order is kind of indeterminate. You can't really rely on things happening in the order in which you actually type them into the code. It doesn't really work that out. It does an internal ordering that I'll mention in a second. One of the examples here that we often use is creating a feature and adding attachment. Okay, so I might use just the EditOperation.create. And then when I look at the add attachment method, it requires the OID of the feature that I'm going to add the attachment to. Well, at create time, I don't know that. Okay, so I have to somehow do the edit to the create first and then add the attachment second. And so you would normally have those as two separate edit operations. And you can certainly do that in code. You can have as many edit operations as you like. The problem becomes, because you've got two separate edit operations, you would have two items on the undo stack, which isn't always ideal. We can combine edit operations, and that's called chaining or chained edit operations. Unfortunately, we don't cover that in this session. It's actually covered in the advanced session. But the keyword there is chained edit operations. And there are some examples there in the help and the snippets to go through that. Okay, and again, there's a code snippet here of creates, modifiers, and some of the actual parameters that you can use. All right, execute is where the magic happens. So what I've done is I've declared an edit operation. I've said what I'm actually going to edit by saying edit operation dot blah, blah, blah. And then when I want to run all those edits, I'm just sort of queuing it up at this point, and then I'll say edit operation dot execute. I said there really wasn't an order, but internally there actually is. Creates run first, updates, then deletes, then everything else. And that's why I say you can't really rely on things being done in a certain order or the order in which you want them to. They are actually done in this internal order. On success, all the edit operations placed on the stack and the edits actually occur on the database. If you do stack up a whole bunch of edits, like 100 creates, and say the last one fails, then we fail all of them. So if one fails, they all fail. We don't want to get the database into this half succeeded, half failed state. So it's an all or nothing kind of operation. The execute also behind the scenes takes care of the plumbing of opening the workspace. So again, if the workspace isn't currently being edited, the execute actually does that at that time as well. So it'll say, hey, can I edit you? Yes. Start an edit session. So it actually starts a transaction on that workspace, performs the edit, and then leaves it open, leaves that workspace open until we close that edit session. The edit operation.execute returns a Boolean to say whether it's succeeded or failed. You can also use another property called edit operation.isSucceeded, and that'll say whether the edit actually, all the edits actually passed. And then we can check for that and do whatever further edits necessary. If an edit fails for some reason, there is also an error message property. This will tell us the reason for the failure if we know. A lot of our edit operations internally, we send it through to the geodatabase, and the geodatabase may be failing for some reason. Maybe there's a permissions problem or who knows what. And if the geodatabase can tell us what's wrong, then it filters the message up to us in the edit operation, and then we just pass it back to you. In a lot of cases, we just don't know. You might get some weird 999 error code, where it happens to be. If we do know, we certainly pass it on, but there's a lot of cases where we don't, but that's the place to check. And this is all putting it together, what an edit operation typically looks like. Again, declaring at the top here. Calling it a name, simple edit 2, select modify features, true. I'm doing a modify, passing it to a layer. The number 1 here is the OID. And I said in a lot of cases, you don't really know what the OID of the feature is. Maybe it's come from a selection set. Maybe it's come from a search that's returned a cursor, for example. So cursors are alive and well in Pro. We don't really show you that during this session. I think they do in the later sessions. Reshape, modify, some extra stuff on the end there, and then the execute. So that's the sort of the typical pattern that you would be using for an edit operation. All right. Once you've done all the edits, you can save them, or you can just leave it up to the user to save the edits if they like. But to call save and discard, you're basically calling save edits async. It's an asynchronous method, or discard. And that's done from the project level. So project is a static class, and save edits async. If you want to know that a project has edits, you can look at the project property called project.current.hasEdits. And this is data edits. We should have probably renamed that method, or that property I should say, to say has data edits, which is different from if you've made edits to the actual project in terms of opening a layout or changing one of the docking panes or whatever. This is specific to, does the edit have any edits in any of the maps in any of the workspaces? Again, save and discard applies to all data edits in the project. So if I'm editing one map and I might be editing another map and I hit save, I'm saving everything. We don't have that choice to say just save the data on this map, don't save the data on that map. Again, we started down the line of making a UI for that, but it just became too complex and we just fell back to saving everything or nothing. All right, let's take a look at a simple demo in action. Oops, I'm going to quit out. Okay, so back to this map here, I've obviously got 3 polygons and I've got 3 point layers, and these are in 2 different workspaces. What I'm going to do in the code is just a very simple edit, and that is create 3 points in the center of the screen and manipulate these particular polygons. So let's take a look at the code here. Let me shrink that. Oops. Okay, hopefully everybody can see that. So here I've created the button and I've just used the SDK templates which fall into Visual Studio. I won't show you how that works, but I've just said add a new item, go to Pro, and make me a new button. And all it does is just stubs out the class name and a couple of using statements and has an empty on click. So what I'm doing here is finding the 3 layers or the 6 layers in my map, and to do that I'm just saying, I won't go through each of these lines one by one, but I'll just go through the overview. I'm just saying map view active, and that's a static class to find the active view in the map, which is usually the map that I'm looking at when I'm pushing a button. And then I'm finding a particular layer, in this case it's facility point 1. So what I'm saying is from the map, get the layers as a flattened list, and that means that if I've got any group layers, it's just going to squish all those down and just present to me a list of layers in the map. And then using a link statement to find that particular layer in the map. If you come from ArcGIS, it's kind of hard to get your head around this whole link and lambda syntax. In Pro, we use a lot more pure .NET calls than we ever did in ArcGIS. So if you are transitioning from ArcGIS to Pro, it's a bit of a learning curve to learn this link statements, and a lot of threading as well, which I'll talk about in a second. The other way to find a layer is also on map view active.map. You can use a method called find layer by name, or find layers is the other way to do that. So here I'm just returning the actual layers, point layers, polygon layers. Okay, then we get down to this qtask.run, and we use that a lot in snippets and examples. You'll see that all over the place. So the Pro architecture, it really has 2 main threads running. We know it's multi-threaded, but there's really 2 main threads that run. One is the UI thread, and that's the ribbon. It's the dialogues, anything to do with what's happening on the screen at the time is what we call the UI thread. The other thread is what we call, normally it's called the main sim thread, or it might be called the worker thread or the background thread. It's not really a thread, it's a thread pool. So it's a whole bunch of threads underneath that. And the best pattern to use in all the samples and all the snippets that you might see is that we shove as much work as we can onto this background thread. The theory being that we want to keep the UI thread as responsive as we can and open so people can do stuff in the map while all your work is happening in the background. So it's a good practice to do that. The other reason why you do that is because a lot of methods are actually dependent on running in the background. They physically won't run on a UI thread, and you actually get a thread exception if you try that. I don't have an example here, but if you hover and get the IntelliSense for an operation, if it's required to run on the background thread, the MCT, it will actually tell you in IntelliSense that it has to be on the background thread. Let's create polygon one. Oh, it is, yeah. So there's the, sorry, I'll move that to the top of the screen so you can see. So here's a method for the polygon builder, and it says in the IntelliSense there, this method must be called on the MCT use qtask.run. Okay, So here I'm just saying qtask.run. Again, this is, if you're coming from ArcObjects, it's a bit hard to wrap your head around, but take a look at a lot of snippets and examples and you soon get the hang of it. All this is doing is saying take all this stuff in this curly brackets and then run it on the background thread. Sometimes you'll see an await at the front here, sometimes you'll see a return. It really depends on how the method's actually set up to how you're calling it. I'm not going to go into much more details about qtask run, but it's another important thing to understand how that actually works. All right, so having said that and set that up, I then get into my edit operation. So edit operation, create a new one, and give it a name. Because I'm just creating 3 points on the screen, not using any existing geometry, I'm just going to grab the screen extent and just use the center of that screen as a starting point. So here I'm just using some more properties of the map view called the center of the extent, returns a map point. If I hover over that, you can see it's a map point. I'm then getting the boundary of the extent, and I'll just shrink it a lot. So I'm just using expand on the extent, shrink it down. Then I'm going to create a polygon at the center of the screen. So this guy here is Polygon Builder, which is another static class. This is part of the geometry library. So when you're using Pro, just like ArcObjects, the main assemblies that we'll use, apart from the editor, is geometry. So we'll use that quite a lot to build points, lines, polygons, to manipulate vertices, to manipulate vertexes, segments. You would use all the methods and properties on the geometry library. It's fairly similar to what it was in ArcObjects. Most of the 99% of the stuff's been ported across, probably. It's actually come a long way from the early days. But most of the stuff for basic editing is now supported in the geometry library. Okay, so here I'm just using a helper method called Polygon Builder to create a polygon somewhere in the center of the screen. There's a line builder helper, there's a point builder helper, multi-patch helper builder? Multi-patch, multi-point builders as well. Okay, so I'm just going to create a polygon somewhere in the center of the screen. Then I get to the actual edit operation itself. So here I'm saying edit operation.create, and I'm simply going to create a point on the points layer 1 using that geometry. It's just one of the overloads that I have. The attributes that it will create with that point are just the default for the actual layer. So that's fairly easy. The other two methods I'm going to create side by side of that point, so points layer 2, points layer 3, and then I'm going to create those points by shifting that point to the right some distance. And to do that shift, I'm just going to call a geometry method called move. And that hangs off another static class called geometry engine. Well, .instance is what it is. So the geometry engine is where you'll find all the geometry manipulation methods and properties. So there's moves, there's cuts, there's splits in there as well. Buffers there as well. And so it's pretty, we kind of duplicate a lot between the edit operation and the geometry engine. For example, to split a line, there is a split method on the edit operation itself, but you can also split a line in the geometry engine. So you have the choice of where do I do the split? Am I doing it in the geometry engine if I just care about the geometry, or do I do it at the edit operation level, which will also handle the attributes? So what you want to happen to the attributes is kind of dependent on what route you would take. The edit operation, which should look after it for you, versus the geometry engine, which is purely concerned about geometry. All right, so I've done that. Then I come to the polygons. I'll just delete one. So it's easy enough to say the layer and then the OID. And we'll look at selection in one of the later examples. And for the other two polygons, what I'm going to do is use a modifier. What I'm doing is modifying the geometry of these existing polygons. So one of the overloads here is to say layer OID and a new geometry that polygon will actually take. So layer OID. And then I'm just replacing it with an actual buffer. Select new features, select modified features. It's true by default, so in this case I just want to turn them off because I don't want to see all the blue selected stuff on the screen. So I'll just set those to false. I can set these anywhere. I don't have to set them when I declare the edit operation. I can do it anywhere in this code. And then to execute it, I just say editop.execute, and that's when the magic will happen. It'll go to the workspace and perform all the particular edits. So if I just set this, I'll do a breakpoint there because I'm actually running Pro here. So I've created this add-in on the add-in tab. That's where it goes by default. Through the config DAML file in your add-in, you can actually specify different toolbars, different ribbons, different tabs to say where these go, but I'm just accepting the default. Okay, so I'll hit run here. So it runs through all this code, and at any point I can just see, hover over one of these and see what the variables are actually doing. So there's my polygon. If I step through these, the creates, I won't see anything on the screen because remember, nothing happens until the execute. So there's no real point to see anything that's happening through these intermediate steps. It's only on the execute where the edit actually gets run. So I'm happy with that. Hit continue. So that's a result. So I've just created 3 points there. Hopefully I'm in an edit session now, and I've just manipulated 2 polygons and deleted one of them. So that's a fairly simple, actually it's pretty silly edit, but it just gives you an idea that I've combined all these into one edit operation. So if I look at the stack there's my name for the edit operation itself. File, edit operation, I can undo and redo that, to my heart's content, and it'll go ahead and do that edit. And discard that at the end. Okay. So that's an edit operation at work. All right, let's move on. All right, hopefully you can see that. Okay, let's take a look at the inspector. So the inspector class says it's a convenient utility class for accessing attributes. It's really the class to access the attributes. It's more than just convenient. So it gives us the ability to access the attributes of a feature, including the geometry field. So it has a property called shape, which we can rip out the actual geometry field from that feature and do things with it. It's also the preferred mechanism now at 2.3 to edit annotations. Does anybody actually do annotation editing here? The one person on the planet? Sorry. So Chip's not here. Yeah. So it was really hard before 2.3. We've actually made it a lot easier at 2.3. It's more how people actually think about editing annotation. Can get the schema information about a layer, not used much these days. I'll get into that in a second. Copy attributes to a new feature, yeah, you can use it for that, but it's not the primary use case. Mostly it's for just accessing and how we edit features, attributes. So the typical usage, very similar to an edit operation. We instantiate a new instance of it using the new. We then load a feature or a bunch of features into the inspector. So if we want to manipulate a particular feature, maybe it's a selected feature on the screen, maybe it comes from a search cursor, we load those features into the inspector. The inspector then represents the attributes of that feature as a dictionary, so a pure .NET dictionary, and you can use the regular dictionary syntax in .NET to access each individual attribute and update those values. So for example, if I wanted to update the building ID field for a building perhaps, I load a particular feature into the inspector and then I can just say inspector square bracket building dot point, whatever it happens to be, equals 2700, and that'll just set that field to that value. I can also use it as a get as well, so I might say var blah equals inspector building ID, and it will just return that value as well. So we made it very easy to update attributes. It's pretty similar to how you would have done it in ArcObjects. Once you've made all the changes to any variables or attributes in the inspector, you can then commit those changes by using EditOperation.modify and then pass it the inspector as a parameter, and that'll get passed through once you run the EditOperation.execute. And that's basically the pattern. Another big thing here is it loads attributes that are joined. So if you have a joined table that you're loading into the inspector, it takes care of that for you, so you don't have to do any weird syntax for any relates or joins. It'll just load those into the inspector, and you can reference those field names as a fully qualified name. So it'll be table dot whatever it happens to be, that particular field. All right? All right. So an example here is the code. Again, QTask run, edit operation, new inspector. I'm then loading a feature into that inspector, so it's layer and then the OID. Load async is also a method that you can use in the inspector, but load is more common. This does have to be run on the MCT, so that's why it's actually run inside a QTask there. Then to update the variables, I simply say the inspector root number 42, name equals building 1, whatever it happens to be. If you want to get the geometry from that particular feature, just a variable geometry, inspector.shape, whatever the shape field happens to be, it works it out, just gets the geometry from it, manipulate the geometry, whatever you want to do to it. The reverse of that, setting the inspector shape to some other geometry which I've created. You then just set it as a variable there. And then lastly, you just say EditOperation.modify, send it to the inspector, and then execute, and then it'll make all the changes that you've said. So it's fairly easy. If you send it the wrong geometry for the shape type, so say you got a polygon and you send it a point, you'll just the execute will fail and the error message will tell you that the geometry is wrong in that particular case. All right. Inspector apply. So inspector has a method called apply. It's an alternate pattern for committing the inspector. So in the previous example, I said EditOperation.modify inspector execute. You can bypass all that nonsense by just saying inspector.apply. So it's useful when you don't need an operation and you don't care about what the name is going to be called on the undo stack. It'll just create one for itself called update feature attributes or something like that from memory. Internally, we still create an edit operation for you. It's just done behind the scenes. But it actually is performing an edit operation. So the syntax for that is instantiate a new one, which we can't see here, load in a feature, set an attribute, and then you simply say inspector.apply or apply async as the asynchronous version of that, and it'll go and do the magic ahead. You can load in multiple features into an inspector from the same layer, not from different layers. And the overload for that is just send a list of longs, an IEnumeral, if you like. If the attributes are different between different features, obviously they probably would be in a lot of cases. If you're trying to get those values out, they'll just be null. But normally you're just setting a bunch of features to the same value. Syntax is down the bottom, load, layer, the OIDs in this case. Here I'm getting a selection. Set the value, and here I'm just saying inspector.apply, and it'll set that value to all those particular features that you have loaded. All right. Schema. You can get the schema for a layer, and what I mean by that is you can get for each field, you can get the field name alias, if it's dirty, if it has edits, etc. And I won't go through this too much. The editor API came out before the geodatabase API, so this is why this exists. These days, we mostly just use the geodatabase or the core data API to get at the schema. I would go through the feature class, the feature class definition, and get at the schema that way. You can use inspector, but like I said, it's not used that much. It does the same sort of thing. All right, copy attributes used even less. Creating a feature from another feature. You can just use some magic here. Some link statements down the bottom, it says, for each and copy. Not often used that much, but that's just an example of how you could use it, for example. All right, I won't dwell on that too much. All right, let's do a quick demo. All right, let's look at some code. What my goal here is, if I look at the attributes, got a polygon, got a description here. I just want to shove something in that description field for the selected feature. So what I'm going to do is, again, I created the button using the templates, jump into QTask run, and here I'm getting the map selection. So I'm just saying map view, active map, get selection. What that returns to me is a dictionary, a pure .NET dictionary of map member and then a list of longs. So for every map member that I have selected, it'll be an associated list as a key for the map member and the values for the actual list of longs. And so if I just hover over selection there, it tells me that. So what I'm going to do is rip out the first feature from that map selection. Create a new inspector. I load in that feature, which is simply just the map member and the OID. So here I'm going dictionary syntax here. Get the keys, get the first key from that dictionary as the layer, and then I'll get the first set of values from that dictionary, which is the enumerable of longs, and then I want to get the first value out of that, which is just the first OID. That's why the first comes up. I then simply say inspector description equals the date, and then simply apply that, and that should do the execute for me as well. If I wanted to use an edit operation in this case, I would say edit operation, call it whatever I wanted to, say edit operation modify, pass it to the inspector, and then say execute. I wouldn't use apply and execute in the same time. It's one or the other. You can't really use both. Which also brings up another point which I forgot to mention. There's no real limit to how many edit operations you can specify in your code, because they're usually kept separate. So you might have a bunch of creates going on in one, then you fire up another edit operation and a whole bunch of creates in the second one. Like I said, they do form two separate operations. Yeah, I won't get into the events at this moment. We'll save that for a later date. Okay, so when I want to run this thing, I'll go to my add-in, have a selected feature, and I simply click the button. I've got a breakpoint there, so just go through. Oh, what did I click? I clicked the wrong one. Let me do that again. Where are we? Update attributes, here we are. Oops, let me undo that. That was horrible. Update attributes. Okay, so then it puts the description simply in that field. So description, attribute. Okay, pretty boring stuff. What happens if I've got no selected features? It's going to crash. So it just comes back and crashes, and I'm not very good at putting error checking in my code. All right, so that'll just crash in a blazing heap. All right, what are we going to do next? And that brings us to annotation. We'll have a period to answer questions at the end, briefly.
All right. Okay. Firstly, we're going to talk about annotation and dimensions really quickly and how they are different from existing point, line, and polygon feature classes. Annotation is a polygon feature class, but the polygon that it stores is actually the bounding box of the text of the feature. And the geometry, the polygon geometry, is actually maintained by the software. So you specifically as a developer don't really want to be interacting with this polygon geometry. You're interested more in the baseline geometry of the annotation text. So anytime you modify any of the annotation text formatting attributes, like the text string or the font size or the font name, you change the font, the software actually recalculates the polygon for that annotation feature. Annotation also has a number of label and symbol classes which are defined at the feature class level. So to get to those particular collections, you go from your annotation layer to the table to get the feature class, and then to the feature class definition using the get definition method. From there, you can get a read-only collection of the label classes and the symbol classes. And the label class and the symbol class is what is used for symbolizing the actual annotation features. The basic feature is represented by an annotation class ID and a symbol ID field at the feature class. And these are actually system fields, meaning that they can't be deleted by the user. So that is your basic SymText graphic or SymText symbol for symbolizing your annotation. You can then do additional overrides on that SymText symbol, change the font color for a particular feature, change the font size for a particular feature, change the font name, the horizontal alignment. You could add a caller or a leader line or a call out for one particular feature within your feature class. And this is done by modifying some specific text formatting attributes. In the ArcMap world, these particular attributes were system fields and you couldn't be deleted by users, and so the schema for an annotation feature class was fixed. This is not the same in Pro. These particular text formatting attributes, whilst they may exist, if you do a conversion from a 10x annotation feature class, they're not system fields, and so they can actually be deleted by the user. So when you're writing your code, you need to be aware that even though your feature class may have a text string field, doesn't mean it's always going to have a text string field because your user may delete it from underneath you. So for that particular reason, we recommend not using the inspector field name pattern. Instead, we have another class that hangs off the inspector called an Annotation Properties class. And you can access this by using the get annotation properties and set it back on the inspector by using the set annotation properties. So what is an Annotation Properties class? It basically holds all of these text formatting attributes that used to be held in these particular fields. So we have a number of common properties to let you change the color, the font size, the horizontal alignment, the text string. You can also use a text graphic property to retrieve the entire SimText graphic. So for something that might be a little bit more esoteric, where maybe you want to add a shadow or a leader line or a call out, you can access the text graphic, access those particular text symbol objects, add your particular leader lines, and assign that text graphic back. We also have a shape property of the Annotation Properties class, and this is actually the shape that you are interested in. It is the baseline geometry of your annotation feature. Remember, inspector.shape is always going to be the polygon shape. The annotation properties.shape is the baseline of your annotation feature. And depending upon how this annotation feature is created, this baseline geometry can be a point, it can be a multi-point, it can be a two-part polyline, or it can actually be a geometry bag if you happen to have stacked annotation. So if you're running code and you're manipulating the shapes or the geometries of your annotation, you need to be aware that that geometry can actually be one of many different geometry types. So here's a small little code snippet of how we do a simple modification of annotation. Again, we use the inspector object, same as Sean was showing. We use the load, passing in a layer and an OID. And then we call the get annotation properties to get our annotation properties. In this situation, I'm going to use one of the common functions or common properties, text string, to change the text. Set the annotation properties back, and then do a standard edit operation modifier, passing in our inspector and edit operation.execute. If I'm interested in interacting with the SimText graphic, then again, I call create a new inspector, load my annotation feature, get my annotation properties. Then I can access the text graphic property. In this instance, I'm getting the symbol on the text graphic, the SimText symbol. I'm going to modify a few properties on that SimText symbol, and then I'm going to load that modified text graphic back to my annotation properties using this load from text graphic method. Set my updated annotation properties back on my inspector, and then again go through my edit operation modifier. Talking about dimensions, anybody interested in dimensions here? Oh, look at that. You told me nobody did dimensions.
Who are you people? Okay, right.
For anybody who's interested in dimensions, can you come and see us at the island? Because we are really interested in getting names and contact information to help us develop the API for specific things that you're doing. So we're really interested. We find it hard to find people who are doing dimension stuff, so you're very special. We want to speak to you. Again, anyway, dimensions, they're the same, very similar to annotations. They are a polygon feature class. They store a polygon geometry which describes the boundary of the feature. Again, it's a geometry that's maintained by the system, by the software, so that's something that you are not typically going to interact with. And in fact, if you do interact with it, any change that you make is going to be overwritten by the software, so it's actually quite pointless. The geometry that you're interested in for dimensions are these 4 points: the beginning dimension point, the end dimension point, the linear dimension point, and the text point. And depending upon whether you're an aligned dimension or a linear dimension, kind of determines how many points, which one of those points are important. Similar to annotation, dimensions also have a class, a style classes defined at the feature class level. So you would go and access them in a similar manner. You have your dimension layer. You can get the dimension feature class by calling the getTable method, and then find the definition, the feature class definition, by calling getDefinition. And then again, you'll get a read-only collection of the styles using the getDimension styles. For a dimension, the most important field is the style ID. Again, that references one element in that style collection. There are no options to store style overrides like there is with annotation. So the style collection of that feature class level has to represent everything that you want to accomplish with your different dimension features. Again, unlike annotation, dimensions actually have a lot of system fields. So when you do a conversion from a 10x dimension feature class, all of the fields that were system fields in ArcMap are still system fields in ArcGIS Pro. For that reason, you can use the inspector field name paradigm. We don't have a dimension properties class because there really wasn't a need to introduce one. So you just use the inspector like you do with standard point, line, and polygon features. Again, inspector shape is the polygon geometry. We're not really interested in that in this scenario because it's not something that you need to update. What you're interested in is the 4 dimension points, and they are accessed by begin X, begin Y, end X, end Y attributes. So let's jump into ArcMap real quick. We've got 5 minutes left. I've got a few simple little annotation features here, and I have 2 tools that I've created, one for modifying annotation and one for modifying dimensions. Running with the annotation one first, I'm just basically going to go ahead and draw a rectangle around the feature that I'm interested in interacting with. Should be starting Visual Studio. No?
What are you seeing?
What are you seeing? My PowerPoint still? All right, let me just kill that. How's that? Perfect. All right, so within Visual Studio, like I said, I have a sketch tool. It's just a simple map tool I've created using a Visual Studio template. And all I've really done is add some custom code into the onSketch complete async call. And that gets fired when I've created my rectangle in ArcMap. And the geometry that comes in is the sketch geometry, the sketch rectangle that I did on the map. And what I'm interested in doing is finding the annotation features which lie underneath that rectangle that I sketched. And so this is accomplished by doing get features. And then this particular line, I'm looking at filtering that for any feature which lies on an annotation layer. From that collection, I'm basically just interested in the first OID that I'm going to be looking at. So here I've got my particular annotation layer, and I've got the first OID that I sketched over. And what I'm going to be doing is simply loading up my inspector with that annotation and OID. You can see that if I look at that shape object, it's a polygon. I can get my annotation properties, and if we have a quick look at this annotation properties class, you can see all of the basic common functions that we let you change specifically through this. So I have color, text case, I can change the angle, I can change offset, it's my text underline, font style, font name, font size, vertical alignment, horizontal alignment. And then, like I said, here's our catch-all. If there's something that you want to do that's a little bit more special or complicated, then you have the SimText graphic, which gives you a whole bunch of additional possibilities for modifying your annotation. Right now, first thing I'm going to do is just a very simple modification. I'm just going to use the common properties. I'm going to change my color, change my case to be all caps, change my font size to be 58. I'm going to look at what my shape is, and you can see that here my shape for this particular annotation feature is, the baseline geometry is a polyline. I'm not going to do anything with that right now, but just so that you could see that in this particular instance I have a polyline. Set my annotation properties back on the inspector, create my edit operation, call modify, and then call execute. So you can see now that this particular annotation feature has got blue text. It's now 58 font, and it looks considerably different from my little baby red ones. If I go and sketch over this particular one, goes through the same code, but what I'm going to do is do the more complicated example where I'm accessing the text graphic. So I go ahead and get my text graphic. I can get my SimText symbol, and if you're done any programming, you know that the sim objects are very low level and you get a lot of different options to change things with the sim. They're not high level objects, and so they're really just really low level, give you a really fine control over whatever it is that you want to do. In this particular instance, I'm changing my color to green. I'm going to go to lowercase, and I want to add a shadow. Now, the shadow was not something that was available on the Annotation Properties, so that's why I have to go to the text graphic. I'm going to set shadow color and a shadow offset, change my size, call load from text graphic back to load that updated text graphic, set my annotation properties back, and then do my edit operation. So you can see this particular one, it's got the green background with the pink shadow. Really quickly, we'll just jump into the dimension one. Again, another sketch tool. I can go out, draw a rectangle over here. Similar thing on Sketch Complete Async. I'm interested in filtering for dimension features. In this particular case, I'm going to load up all the OIDs I found rather than just the first one. Create an edit operation. I'm interested in changing the dimension value to show a custom length. So again, just using the inspector field name paradigm. Modifying the inspector, executing the edit operation. So that you can see that these two dimensions now, instead of showing the actual dimension value, select. So this was my original, what's my original value? This was my original dimension value, and now instead I'm throwing a custom value in there and displaying my custom value. If I undo, again, we'll go back to what our dimension value was. So that's all we have for you, and I think we've just about run out of time. We got pretty close there. Here's a couple of slides showing the next schedule for tech sessions for Pro. There's obviously a number tomorrow, some things about the sim. If you're particularly interested in more about the sim, more about mapping and layout APIs, we have an intermediate editing session tomorrow where we're going to talk about construction tools and how you might create a modify tool and have that embedded in the modify features pane or add it into the gallery, and how you can add UIs to those particular customizations. Some sessions on Thursday. Advanced editing on Friday morning. If you've got to be up bright and early for that one. So do I. And then a couple of demo theatres and the all-important Road Ahead session on Thursday afternoon. So does anybody have any questions for us? Perfect, we've done our job. No questions, nothing? 2. Mm-hmm.
Basically do them in separate queue tasks and use the weight for them?
I would do them in the one single queue task. From a performance point of view, it's really bad to be going to the background thread, to the UI thread, to the background thread, to the UI thread. It's not very.
Would you basically, I'm asking, would you use the weight for those tasks, or because he said that they go out of order. So I guess if you just use the weight and you wait for that one to finish, then you
No, you don't need to save your edits between. So what you would do is you would jump to the background thread, create one edit operation, and do your edit operation.create. Then do your edit operation.execute. Then if that succeeds, edit operation.create chained operation, a chained operation.add attachment, chained operation.execute, and then jump out of your background thread. Okay. I have a snippet. Actually, if you want to take a photo, I can jump one up there real quick for you. I think I have a,
Which one are they?
sorry?
Yep.
Yes. Yes, in the
Yep.
GitHub, there's an example of how to chain to. So here's quickly, I'm on my queued task. I have my edit operation. And I'm doing a create. And then if I succeed on the execute, I create my chain, add my attachment, and then execute my chain. And so that gives me one operation on the undo stack. And when I undo, I'm actually undoing my attachment and my creation together. And then if I redo, I'm redoing my creation and my attachment together. Okay? Okay, and then your question? Yeah, if they're in the same layer, you can use load, passing in a layer and an enumeration of OIDs. Okay, and then if you want to modify them all to the same particular attribute value, yes. If you want to give them all different attribute values for that one attribute, then you need to load them separately, assign the attribute, do the modify. Clear it, load the next one, assign the attribute.
Yeah, when you do the load, it's the last one wins, so you can't say load and then modify and then load again, because it'll just overwrite the first one that you actually loaded. So you do need to load and then execute it first.
If I have a look here, quickly going here, here's the standard one, map member and a single OID. Or you have load with map member and a set of OIDs. Yeah? Okay. Any other questions? Sure?
With the inspector, when you're loading items, are you able to load just a selection? Give yourself a lot of performance increase? I mean, if you're really large, then
Again, if they all come from the same layer, yeah. So you've got that, you've got a layer and then you get the selection off that layer. You can pass that in via layer.set of OIDs, yeah. Okay, great. Thanks for coming, everybody. And hopefully we'll see you tomorrow night for the intermediate session.
Cool.
If you got any other questions, we're at the island tomorrow as well.